Hey, today we're talking about real numbers and their properties, and we are basically bringing together everything that we've been talking about this chapter. So, just to recap and let you know how they're all related. The first set of numbers that we talked about were your natural numbers, okay? Sometimes denoted with the letter N. Those are the numbers that you first learned to say when you were very young, 1, 2, 3, 4, as high as you could count. They're also referred to as the counting numbers. The next set of numbers that we have are the whole numbers. They are denoted with the letter W, and the difference between the whole numbers and the natural is that now it includes the number 0. Okay? The next set that we have as we move out in our diagram are the set, or excuse me, is the set of integers. Okay, integers are denoted with the letter Z because I is reserved for a different set of numbers. And that's when we got into the positive and negative whole numbers. So -3, -2, -1, 0, 1 is high. So we go to infinity in both directions. Then we have the rational numbers. Okay, and I'm using some symbols. That's what we just talked about in the last lesson. They are often denoted by the letter Q, and if it helps you to think about that, you don't have to know these letters. I'm just doing it to abbreviate it and relate it to the diagram. Um, but the letter Q might perhaps stand for a quotient because the rational numbers is any number that can be written as a quotient of two integers. So A and B are elements of Z, and of course, B cannot be 0 because we cannot divide by 0. Okay? Then, if they're not rational numbers, actually, yeah, if they're not rational numbers, that's what we talked about yesterday, then they are irrational numbers. That is denoted by the letter I. And examples of irrational numbers are any of those square roots that weren't perfect squares. The number pi. We talked about decimals that have a pattern. Oops, there's not a comma in the middle of a decimal. Thanks. 1.01011. There, I did it again. I'm going to erase it this time because, yikes. Thanks. Okay. 1.010110111. The point being is the decimal has a pattern. It does not repeat and it does not terminate. And then all of those, our rational numbers and our irrational numbers together, make up our real number system, all the numbers that you know. And that is denoted, some books use a little fancy R, some of them write the R with a double line. Both of those symbols mean the set of real numbers. Okay, so we're going to go talk about properties of these real numbers. You don't have to memorize them. I will give you a list, but I'm just going to talk through them quickly and then go through the problems that you'll have to practice with. Okay, first off, we have a property. I don't know if you've ever heard this before. This is the closure property of addition. And that means if you add any two real numbers, you always get a real number. Okay? There's some examples that you can go through. I want to go through it quickly. Okay? If you have any questions, then please come and see me. Then we have the closure property of multiplication that says if we multiply any two real numbers, we always get a real number. Okay? They give you 10 times 1/2. That's equal to 5. That's also a real number. Okay. Next, these should be more familiar to you because you've talked about them in several of your classes. All right, the next two properties that we have dealing with changing the order, okay? And you have heard of this before. They are called the commutative property of addition if you change the order that you add the numbers, or it's called the commutative property of multiplication if you change the order that you're multiplying. Either way, the point being is it doesn't matter if you change the order, you will get the same thing. So when you're looking at your numbers on both sides of the equation, look and see if they changed order. 13 plus 7, it's not still 13 plus 7. The other thing to help you remember that, it is commutative, not commutative. Commuting is when you commute back and forth to work. That's moving back and forth to work and having to do with changing your order, changing your position. All right, the next group that we have is one that has to do with what's inside of the grouping symbols. So if you are changing your grouping, okay, only what's inside, think about your group that you hang out with. That is your associative property of addition if you're adding, and it is multiplication if you're multiplying. So when you look at these and you're trying to determine, look at the order and you will see that it's A, B, C, and A, B, C. The order that I wrote these things didn't change. What changed was what was inside the parentheses. Over here I have A plus B, and over here I have B plus C. So the overall order did not change of these programs. All right, the next one we have, you're all familiar with it, is called the distributive property, generally one of the easier ones for people to find, that multiplication distributes over addition and of course subtraction because that's basically the same. Okay, then we have the what we call the identity property of addition or additive identity. Identity property of addition, and we have the identity property of multiplication. Okay, the identity, your identity is what you see when you look in the mirror. So if you add something, you get exactly what you started with. You get what you see in the mirror. Doesn't matter the order that you add them. So your additive identity is 0, and your multiplicative identity is 1. When you multiply any number by 1, you get what you started with. Okay, and then the last one we have is the inverse property of addition and the inverse property of multiplication. And what you probably didn't realize is the inverse is what we add to something to get back to the identity. Okay? Or in regards to multiplication, it's what we multiply a number by to get back to the multiplicative identity, which is 1. Additive identity is 0. All right, so let's go look at the types of problems that you're going to have to practice with. I'm going to do number 30. It says, list all the numbers from the given set that are natural numbers, integers, irrational, whole, rational, real. Actually, I'll go in order. I didn't read those in order. So I'm doing number 30, and part A says, which one of these are natural numbers? Okay, that's not a natural number. If I look at square root of 49, you need to recognize that as 7. The square root of 50 is a decimal. So the only natural number that I have in this list is going to be, now I don't write 7, I write the number that's in the list. So I'm going to write the square root of 49. All right, part B says, which of these are whole numbers? Whole numbers are 0, 1, 2, 3, 4, 5, on and on. So it's going to be 0 and the square root of 49. And one of the things about this diagram is if you list something as a natural number, every natural number is a whole number. Every whole number is an integer. Every integer is a rational number, and every rational number is a real number. So if you list something here, it's going to be in each of those groups as well. So now if I go to part C, part C says which of these are integers. Well, I'm obviously going to have those two, but are any of these others integers? And negative 7 is one. So I'm going to list negative 7, comma 0, and the square root of 49. And then if I go to D, I might run out of room. Let's go over here. D says which of these are rational numbers. Again, all of those are rational numbers, and what I get to add to the list would be that repeating decimal. So it'd be negative 0.6 and then negative 7 and 0 and the square root of 49. Okay, then I have E asks for irrational numbers. Well, irrational numbers and rational numbers, they cannot be both. So any numbers in these lists that I haven't listed would have to be my irrational number, which is going to be the square root of 50. And then F asks for real numbers, and all the numbers that you've dealt with are real numbers, so I'm just going to list them the way they are here. So that's what you need to practice. Make sure you can see the difference in each of those. Okay? Give an example of an integer that is not a whole number. Okay? If it's an integer and not a whole number, that of course would be any negative number. So I'm just going to pick one and I'm going to go with -2. Any negative number will work. Give an example of a rational number that is not a natural number. Rational numbers are my fractions, okay? And all the fractions are not natural numbers, so I can just pick a fraction. So think about that as you go through. You got the idea. Completing each statement. Again, the point of it is I don't want you to necessarily remember you need to know what the name of it is. I'm going to give you a list of them, but you got to be able to recognize it. So when you look at this problem here, it asks me to complete the statement to illustrate the commutative property. Commutative says I can change the order. So the square root of 5 times 4 is the same as 4 times, what am I missing? But the square root of 5. Okay, down here with the associative, 379 would have to be 379 because I didn't change the order. What I changed was inside the, oh, I didn't write 9. That's what happens when I don't have students in here telling me what to do. That was supposed to be a 9. Okay, in here in the parentheses is 3 and 7. Over here we have 7 and 9. So you've got the idea to fill in those blanks. Then we have some examples where you get to practice using the distributive property. Okay, so I'm going to do 2 of these to make sure you understand what you're supposed to do. 4 times 3 is 12. 4 times the square root of 5. 4 is on the outside, so it's going to stay on the outside. Okay, if I do 54, square root of 7 times 9, 9's on the outside, square root of 7's on the inside. Square root of 7 times the square root of 7, we talked about that yesterday, that's 7. So your answer would look like this. Okay, in the last couple of problems, you just have to identify the property. And I want to do these because I want you to know what I'm expecting you to write down when you answer these questions. Okay, when I look at this, 58, I'm going to work through some even problems. 58 says 11 times parentheses 7 plus 4. And on the other side, they wrote 11 times 7 and 11 times 4. So hopefully you can see that what they did was they used the distributive property. Go down to 60. 6, 2, 3, 6. Oh, okay. What's inside my parentheses is the same, but the order changed. So this is actually commutative, not associative, which is what it would look like. I was supposed to say property. Commutative property of, you got to tell me the operation. Okay, I changed the order that I was multiplying, so that's why it's commutative property of multiplication. Okay, let's go down to 68. Okay, I'm looking at 68. 17 plus 0 equals 17. I see the same thing I got out. This is the additive because I'm adding identity. Actually, look at 66. Square root of 2 times pi, pi times square root of 2. Again, commutative property of multiplication because I changed the order that I was multiplying. Okay? And the last one I want to look at, and I'm going to let you get started. The square root of 2 plus square root of 7 plus negative square root of 2 plus square root of 7 equals 0. This is the opposite of that. So that's like the property that says A plus negative A equals 0. So hopefully you can see that that is the additive inverse. All right, do your best on those, and if you have any questions, please come see me.